Welcome back. Let's look at chapter on data structures. In this chapter, we will be discussing data structures like set, lists, dictionaries, and tuples. Okay. So to begin with, let's start with list. List supports these many functions. You can have a look: append, extend, insert, remove, pop, clear, index, count, sort, reverse, and copy. Let's see how we can use them subsequently. Say, let's say there is a list with orange, apple, pear, banana, kiwi, apple, banana. If you say fruits.count apple, how many times apple has occurred? That is 2. Like count tangerine, like there is no tangerine, 0. Index of banana, like in this case, the first place where it is appearing, 0, 1, 2, 3, the value 3 is printed. Fruit index banana 4, like after fourth index, like wherever banana occurs, this is a place, that is 6. Okay, like you could also say fruits dot reverse. And when you say fruits, okay, like in the reverse order, it prints banana, apple, kiwi, and so on and so forth. Like if you say fruits dot append grape, grape gets appended to the end. Now when you print fruit, like the grape gets printed here. Like you could also say fruits dot sort. When you say sort, alphabetically they get sorted. A starting with alphabet A, like till P, and then if you say fruits dot pop, always pops from the end. So like it pops here. Okay, so like we just saw how to make use of functions like count, index, reverse, sort, and pop. Now let's look at using lists or stacks. If you know, like if you would have studied stacks and queue, you know very well. Stacks is always last in, first out. Okay, so like let's create a stack with 3, 4, 5. Let's append 6 and 7. Now at the end of this instruction, it will be 3, 4, 5, 6, and 7. Like that's what is getting printed. When you say pop, 7 gets printed, and like stack gets reduced to 3, 4, 5, 6. Okay, yeah. And if you say pop again, 6 again, it's from last, so 6 gets popped. Now it is 3, 4, 5. If you say pop again, 5 gets printed, and now if you print a stack, it will be 3 and 4. Okay. Now, how do we use lists for queues? Okay, queue, as you know, it is first in, first out. Okay. The way to remember it is like you imagine any queue. Whoever comes first, they will be served first. First come, first served. That is FIFO. Okay, first in, first out. So you can create a double-ended queue. Like for that, you will have to make use of from collections import. Like if you do like Eric, John, Michael, and you append Terry and Graham, like they both get appended to the end because it is Q grows on the Q's end grows on this side. Okay, so it becomes Eric, John, Michael, Terry, and Graham. Now, if you say pop left, Q pop left, the first element, that is Eric, gets popped. Okay, now it is like John onwards. Again, if you say pop left, John gets printed. Now, if you print Q, like we had Michael and Terry and Graham, we had appended, so it is Michael, Terry, and Graham. You try out some simple programs, you will get it. Now, let's say list comprehensions. We create a square list, empty list, okay, for x in range 10. Whenever you say range 10, it starts from 0 till 9. We say squares dot append x to the power 2. Okay, so all square numbers till 9 get printed. Okay, 0, 1, 4, 9, 16, 25, 36, 49, 64, 81. Next is like this is like these two are equivalent. Let's look concentrate at this. Like here, what we are doing is squares is constructed as x to the power 2 for x in range 10. This is same as this statement. This is same as this. So like when you do this, what we get is 0, 1, 4, 9, 16, 25, 36, and so on, so forth till 81. The same thing can be done using map function also. So whenever you say lambda x is x to the power 2 range 10, now like this map like returns a value from here. Like we create a map with values 0 till 81, and then we create a list. So all these three are equivalent. Now let's look at this. We are creating a tuple xy for x in 1 2 3, for y in 3 1 4. Okay, if only x is not equal to y, what are we doing? What are we doing is, like, we are doing a Cartesian product of this set and this set, not exactly set of Python, mathematically I'm telling you. So where for cases when x is not equal to y, that is case 1 and 1 and 3 and 3. So we will get 1 3, okay, and then 1 is equal to 1, that is ignored, 1 4, 2 3, 2 4, 2 also 2 1 2 4, and then 3 3 1 and 3 4. Okay, just have a look at it. What we are doing is we are creating a tuple with x and y, x taking value 1 to 3, y taking value 3 1 4, and whenever x is equal to y, we are skipping that. Okay, now this is equivalent to this thing, this is equivalent to this, but this is more readable, as you see. Okay, when like if you print comps, you see the same values over here. Okay, now let's look at another thing, vector here. Okay, we create a vector with value -4, -2, 0, 2 and 4. Now if you say x into 2 for x in vector, like, it is -2, -4, 0, 4 and 8. Okay, now if you say x for x in vec, if x is greater than or equal to 0, meaning we are just picking these values 0 to 4, that gets printed here. Okay, other thing is like absolute of x for x in vector. So, like, we are printing absolute values. Absolute value of -4 is 4, absolute value of -2 is 2, 0 is 0, 2 is absolute is 2, 4. So you get printed like this. Okay, next is fresh fruit, banana, loganberry and passion fruit. See here, there are spaces over here, spaces over here. What you can what you do is, weapon is, weapon is fresh fruit, weapon in fresh fruit. So weapon takes value banana, loganberry, passion fruit with their trailing spaces. When you strip them, you get three banana, loganberry, passion fruit without trailing spaces. Okay, now let's look at this. We are constructing tuple x comma x to the power 2 for x in range 6. So x in range 6 will take value 0 till 5. So what we are doing is we are taking 0, that is 0 0, 1 to the power 2 is 1 again, 1 square is 1 only, and then for value 2 it becomes 4. Okay, for value 3 it becomes 9, 3 and 9. For value 4 it becomes 4 and 16. For value 5 it becomes 5 and 25. Okay. Now, however, if you take off these two brackets, like in this case, you get a error saying syntax error. Now let's look at a vector with value 1 2 3 4 5 6 7 8 9. What we are doing is, okay, we are saying num for lm in vec. Okay, now lm in vec, when you say, you lm will take value 1 2 3 4 5 6 7 8 9. Okay, now, and then what we are saying is for num in lm, lm would have given us a list of containing 1 2 3, second list consisting of 4 5 6, third list consisting of 7 8 9. What we are saying is for num in lm. Okay, so what happens is, from 1 to 3 list we print 1 2 3, from the second list we print 4 5 6, from the third list we print 7 8 9. Okay, I'll repeat. When you say lm in vec, okay, we get single dimensional lists. Okay, and then from those single dimensional lists we pick the number num. Next is we are importing math library. What we are doing is, for I in range 0 to 6, that is values till 5, from 0 till 5. pi, we are rounding pi to value 0, 0, 1, 2, 3, 4, and 5. So here in this case you see this is rounded to 5 digits. Okay, this is rounded to 1, 2, 3 digits, 4 digits, and 5 digits. Okay, so yeah. Now let's look at lists of lists or nested lists. Okay, as we call it, matrix is list of lists. So here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Three lists are there, and then matrix is list of list. So if you say row of I for row in matrix, okay. So now what we are doing is, again for I in range till 4. So what we are doing is, right, this gets for row in matrix. Okay, row I, so row I, how we are constructing it, we are constructing it by taking values at the 0th location. Okay, for this list, value at 0th location is 1, 5, 9. Okay, 159. And then when it takes value 1, 2, 6, 10. When it takes value 2, 3, 7, 11. Okay, when it takes value 3, it is 4, 8, 12. So it gets printed like this. This is a transpose of a matrix. And if you have studied matrix in your lower classes, you will very well notice it is a transpose. So other way of doing it is same thing, like first construct an empty transposed list, and what you do is for I in range 4, transposed append row of I for row in matrix. When you do like this, you get the same thing, but this is more convenient to read. Okay, so this in turn is same as this. So it totally depends, how you want to implement it. For I in range 4, so it takes values 0 till 3. For row in matrix, okay, matrix we have defined up here. Okay, and then row in matrix transposed append row I. Okay, so this again gives a transposed, but the best part is zip, right? If you make use of zip, the way zip works is it picks directly it picks 159 at the 0th value, and then at 1th value 2, 6, 10, 3, 7, 11, 4, 8, 12. So nobody generally writes any of these like this long ones. It's always better to make use of libraries. Okay, so here that's what they are telling. You should prefer, okay, you should prefer built-in functions to complex flow statements, because your code will be maintained by somebody else, right? So the code should be readable. Okay, now let's look at del statement, right? We have already discussed, right? Lists are mutable, you can mutate them or change them. So if you say del a0, okay, -1 is gone. Okay, del 2 to 4, right, -1 is gone. Now you have like this list is there. Okay, what you are doing is you are printing that, and then from 2 to 4 you are removing, slicing. So 333 is gone. Okay, like what you have is 166.25 and 1234.5. Now what you are doing is slicing again. You are not passing any values to the slicer, meaning whole thing is gone. Okay, a empty list. Okay, if you say del a, even that is gone. Okay, now let's look at tuples and sequences. Most important thing that you need to remember is again tuples are immutable. Okay, so let's construct a tuple like this. If you print t of 0, this gets printed. If you print t, whole of tuple gets printed. Okay, now what you need to do is if you say u equal to t comma 1 2 3 4 5. Okay, so a new tuple gets constructed like this. Okay, 1 2 3 4 5, and that gets appended to t was this. Okay, now this is the thing that we were trying. If you try to mutate or alter the tuple, you get exception which says tuple object does not support item assignment. And yeah, if you do v equal to like this, uh, V is a tuple consisting of two lists, but these internal objects can be mutable. List is mutable within tuple, so this is possible here. Now you can construct a empty tuple, or you can construct a single item tuple, right? In that case, you have to put a trailing comma, like he calls it as ugly. Yeah. And then when you say length of empty, because this is an empty tuple, 0 gets printed. Length of singleton, 1 gets printed. You could also do multiple tuple assignments with one value. Now let's concentrate at set. A set, as you know, is a data structure which supports only one type of only supports unique entities within it. Okay, I'll tell what I mean by that. Let's say we create a basket. Okay, there are two instances of apple and two instances of orange. When you create like this, this extra apple goes off, extra orange goes off, so you have orange, banana, pear, apple. Okay. You say orange in basket. Is there orange in basket? Yes, true. Is there a crabgrass? No, it is not there. Now you create a set with abracadabra and create a set B with Alakazam. Okay, Alakazam. Now if you print A, only unique values gets printed. So it is A, R, B, C, D. Like you could do set operations A minus B. All the elements that are there in B, which are also there in A, get removed. So what you get is RDB, like it is A or B, all the unique values in both the sets get printed. A and B, this is like union, this is like intersection, and this is XOR. Okay. Now XOR is letter in A or B, but not both. Okay, OR operation is XOR operation is that. This is XOR. This is OR. This is XOR. Okay. Now, yeah, let's look at for X in abracadabra. If X not in ABC. Okay, like when you do something like this, X gives values, all unique values, if X is not in ABC. So it should be a value from this, but it should not be ABC. What is that? That is RND. Now let's look at dictionary, another kind of data structure. So it will have key values like jack and value, shape and value. So you say tell Guido 4127. So you are adding Guido to tell. Okay, now it gets grown like this. It gets grown like this. Like if you say tell Jack, we print the value corresponding to key Jack, that is 4098, that gets printed. You tell it say this is gone. Okay. Now you are adding I with value 4127. Now what is the value of tell? Tell will have Jack, Guido, IRV. Okay. Now if you say list tell, all the key values, right? Jack, Guido, and IRV get printed. Sorted. When you sort it alphabetically, it gets sorted. Guido, IRV, Jack gets printed. Okay. Now Guido in tell, is Guido in tell? Yes, true. Is Jack not in tell? False. He is there. Okay. Now if you say Jack like this, okay, sorry, dictionary equal to like this, it is also possible to construct a dictionary like this. Now X colon X to the power 2 for X in 246. Now it becomes 2 colon 4, 4 colon 16, and then 6 colon 36. That is what is here. Now you could also construct a dict like this. It is more readable than this, so that is also possible. Now let's look at looping techniques. Yeah, you could have a dictionary like this. Galahad the pure, Robin the brave. Now, for KV in Knight's items is till this one item, this is second item. Okay. what we are doing is print KB. So when you print like this, it becomes Galahad the pure, Robin the brave. You could also, this is yet another looping technique, like, you could say for I comma v in enumerate tic-tac-toe print iv. So like, what happens is, like, I takes value 0 1 2, and when it takes value 0 1 2, we pick v from these values, enumerate tic-tac-toe. So it is 0 tick, 1 tag, 2 2. Okay, so yeah, this is a list of questions. Okay, this is a list of answer. Now what you could do is for QA in zip, question and answer. So when you say zip, this and this get picked, this and this get picked, this and this get picked. Okay, so values at 0th index, and then value at 1th index, and then value at 2nd index. So what we are doing is, like, format QA. So it becomes like, the question is, what is your name? Lancelot. Quest, the Holy Grail. Favorite color, blue. Okay. Yeah. Now let's look at this. What we are doing here is range 1, 10, 2, like starting from 1 in step of 2 till 10. So what are those values? 1, 3, 5, 7, and 9. We are reversing it. So that becomes 9, 7, 5, 3, 1. Okay. Now let's look at a basket, which is a list. For I in sorted basket, print I. So like, we are sorting it. Okay, basket, we are sorting it and printing. So apple, apple, banana, orange, orange, pear. Now, yeah, we are here, the difference is set. Okay, set basket. When you say set, duplicates drop off orange. So if you print it, what you get is only one apple, one banana. Okay, because we are also sorting it, orange and pear. Yeah, next what you could do is, like, math library we are importing here. Like, we are having certain not a number of floats within the list. What we are doing is, if math dot is not a number, okay, like, filtered data is empty list to begin with, and we are going on appending. So all these things go off. NaN go off. Okay, what we get is 56.2, 51.7, 55.3, 52.5, 47.8. Don't worry, like, I'm covering too many like syntaxes and things like that. At the end, we'll have like, practical programs. Okay, so now this string to string 3, we are assigning them to these values. Non-null is equal to string 1 or string 2 or string 3. Like, what is happening here is or is there. So the first movement, like, it encounters Trondheim, like, that value gets assigned to non-null. Okay, I'll repeat. Non-null is equal to string 1 or string 2 or string 3. This is, like, yeah, like, it is this or this or this. Okay, like, non-null, when you print, okay, string 1 or string 2 or string 3, Trondheim gets printed. Yeah, you could also compare sequences. Like, you will get a bool value, you can check it. Yeah, now we covered till chapter 5. Now chapter 6 will take in next session. Till then, thank you.